Okay, good morning class. Right, so for today, can you please click this link first? And I will give you a code. And 72775. Okay, so that's the code. Can monitor please check we're still not here? So for those who just entered the class, okay, just join. I will give you a link. Okay, and then also the code. Okay, for those who just enter, I will give you the link and also the code. Okay, two more person. Okay, who's still not joining the link. Should be 35. Okay, so 35, three more. Okay, so I will start first the class. Okay. Alright, so before the school holiday, right? So before the school holiday, okay, we already learned about refraction of wave. Okay, so for the refraction of wave, you already know that before and after the reflection, okay, the frequency will not change, right? The frequency of the wave will not change. Okay, but the thing that will change is the velocity, right? The direction of the propagation and also the wavelength. Okay, so that is the three things that will change, okay, after the wave being refract. Okay, so for number 3, so here we see the question. It says a diagram shows a water wave move from region P to region Q, okay, at different depth, right? So here it said which region is the shallow region and why. Okay, so for this one, which one is the shallow region? So how do you know that whether it's P or Q that is the shallow region? So which one is the shallow region? Which one is the shallow region? Anyone want to try? Which one is the shallow region? Hello? Which one is the shallow region? Whether it's P or Q? Q. Okay, very good. So Q is the shallow region. Okay, for the deep region, usually the wavelength is longer, right? So which one is the shallow region? So the answer should be Q, okay, because the wavelength is smaller. Okay, and then you have to compare the frequency and also the speed, okay, of the water wave in the both region. Okay, for the speed and also for the wavelength. So for the speed at P is higher than Q. So this one we use the formula V is equals to F lambda, right? V is equals to F lambda. So if the wavelength increase, okay, the speed or the speed also will increase. So here you can see the wavelength of P is higher than Q, means the velocity for or the speed for the P also will be increased. So when the lambda increase, the wavelength increase, the speed also will be increased. So speed at P is higher than Q. Okay, but how about the frequency? So just now, like I said, okay, the frequency for the refraction of wave, okay, there will be no change, okay, there will be no change, okay, before and after the refraction. Okay, for number 4, it says here diagram shows a star-shaped tank with 3 regions, X, Y, and Z, with their respective increasing depth, right? So a vibrator produces a plain water wave in region X and move to region Y and Z. Okay, so draw a diagram to show a refraction of wave, right? So starting, let's say, from Z. Okay, so here starting with Z. So you can see here the depth of the water is decreasing, right? The depth of the water is decreasing. So when the depth of the water decreasing means the wavelength also will be decreased. Okay, so here you can see the depth of the water is the higher at the Z, okay, higher at Z. So you can see the wavelength here is bigger, right? And then in Y, and then it keep decreasing. Then at Z, okay, it become smaller. Okay, so means the deeper the depth of the water, right, the higher the wavelength. Okay. So for this one, you have to discuss the natural phenomena of refraction of wave. Okay, so this is the movement, okay, movement of seawater wave front, okay, from the open sea towards the seashore is shown in diagram below. Okay, so this is the wavefront here. You can see the change of the shape, right? So this is the cape. Okay, so this is the cape. Okay, at this part, this is the cape, and this is the bay, right? So at the cape, you can see the region here. There is a shallow water region here. So here we have a lower speed. Okay, lower speed. As you can see, the wavelength here also is smaller. So mean it has a lower speed at the cape. Okay, while at bay, you can see here they have the higher wavelength. So means the higher speed at the bay, right? And you can see the energy here also. Okay, the energy here also is being diverged. Okay, it being diverged. Okay, it being diverged. Okay, at the bay, while at cape you can see the energy here is being converged, right? It's being converged to one point. Here you can see the energy is being diverged. Okay, so see the arrow here is being diverged. So the energy is being diverged or being dispersed. Okay, while the cape, you see the energy is being converged, right? So this is why the shape of the wavefront, okay, is different, okay, between the cape and also at the bay, right? So why the wave become closer to each other and follow the shape of the shoreline when they reach the beach, okay, when they are approaching the beach. Okay, so the water wave travel from the deep to shallow region, right? So this is the deep region, and then it travels to the shallow region. Okay, so the wavelength or the speed, okay, of the wave will be decreased. Okay, as you can see, we already see just now. All right, if the depth of the water decrease, the wavelength also will be decreased. Okay, so when the When the wavelength decrease, the speed also will be decreased because of this equation. Okay, when the wavelength decrease, the speed also decrease. So the water wave refracted towards the normal line. Okay, so the water wave refracted towards the normal line. Okay, and then for B, why the water at Cape has high wave? Okay, so more energy is converged at the Cape area, so the water at the Cape will has a high amplitude. Okay, just now like we see in the diagram here. So why is at the Cape, okay, there will be the high wave there. Okay, because you can see all the energy, okay, is being converged right into one point. So all energy will be pointed at the one point here. So that's why here at the Cape, okay, you can see there is a high wave because of all the energy will be converged here. Okay, at the bay you can see the water or the beach is more calm. Okay, why? Because all the energy is dispersed, okay, or being diverged, right? Okay, so here why the water is that bay is calm, okay, because the energy of the water is spreads, okay, to a wider area. So the amplitude of the water wave is low, so the water at the bay is calm. So just now like we see in this diagram, you can see the energy is being dispersed or being spread, okay. So here means the energy will be lower here. So that's why at the bay, the water is more calm, okay, if you compare with the Cape, because the energy, all the energy will be converged into one point. So that's why they produce the high wave at the Cape, and why at bay, because the energy is being spread or being dispersed, or you can say being diverged. All right, so that's why at the bay the water more calm, okay, because the amplitude also will be decreased. Okay, next we have to, that one is for water, right? So what happened when for the sound wave? Okay, so you already know for refraction, there will be a light, okay, refraction of light, refraction of water wave. Okay, just now we already see, they say the water travel from the depth to the deep, from the deep area to the shallow area, what will happen? So that one is for refraction of water. So the next one, we have to see the refraction of sound. Okay, so this one is said you have to compare the refraction of sound wave during the warm day and the cold night. Okay, so compare the speed of the sound wave in the warm air with cold air. So why? Okay, so the speed of sound in warm air is greater. Okay, the speed of sound in warm air is greater. Why? Because warm air, they have a high kinetic energy, means the molecule move faster. So when they move faster, they can transfer, okay, they can transfer the sound energy faster, because you already know sound energy, they need a medium to be transferred. Okay, they need a medium to be transferred. They need the air molecule to be transferred. So when they need the air molecule, if the air molecule move faster, mean it can transfer the energy more faster. Okay. So it says here the temperature in warm area greater. So the air molecule gain more kinetic energy and it move faster. Okay, so that's why at the warm air, the energy will move faster because of the kinetic energy. Alright, for number 2, it says here, explain why sound cannot be heard, okay, cannot be heard over a long distance on a hot day. Okay, sound wave travel faster in warm air. Okay, so during the daytime, okay, so here, okay, at the bottom part here, okay, so this one will be hot air, okay, or warm air. So usually the warm air, they have a low density, okay, but the cool air, they are more denser. So they will be at the top of the layer of the air, and the warm air will be at the bottom part. Okay. So and then on the hot day, okay, the layer of the air near the surface to be warmer. Okay. So during the hot day, here at the bottom part, okay, the air layer will become hot, right? And the sound will travel from the hot to cold air. So from hot to cold air. So from the less dense to the dense. Okay. So for the less dense, okay, to dense area, so you already know, okay, let's say from the, for the light also, right? If the light travels from the dense to the less dense, it will refract it away, right? It will refract it away from the normal. Okay, but for the less dense to dense, it will refract it towards the normal. So let's say if this is a normal line, so it will move towards the normal line. Okay, so it will move towards the normal line. So that's why, okay, you cannot hear the sound, okay, so clear during the daytime. Okay, because the air travels, the sound travel from the less dense to the denser medium. Okay, from the less dense to the denser medium, and uh, the the sound, okay, the sound will be refracted, okay, will be refracted closer to the normal line. Okay, so it will be closer to the normal line. So when it closer to the normal line, so the sound will be not heard during the daytime. Okay, so it refracted towards the normal line. Okay, so let's say this is the normal line. Okay, so you can see it become closer, right? Okay, become closer to the normal line. Okay, so that's why you cannot hear the sound, okay, so clear during the daytime. Okay, so it will refracted away from the earth. Okay, and then what happened during the night time? So during the night time, you can hear the sound, okay, clear, even it's very far. Okay, so why? So now, okay, since during daytime, right? So during daytime, so at the bottom part here, okay, at the below the layer of air here, okay, at the bottom of the layer air here, so this one there will become cool air. Okay, so the cool air, and then at the bottom, at the upper part of layer will become the warm air. So here it means it travels from the dense to less dense. So dense to less dense is refracted away from the normal. So if refracted away, it will become like this. Okay, so that's why you can hear the sound clearly even at the at the night time. So at the night time, okay, so the ground become cool, so air layer near the ground will become colder. Okay, and the sound will travel from the cold to hot air, so the speed of sound will be increased. Okay, so the sound will be refracted away from the normal line. Okay, and then the sound wave will moving towards the earth. Okay, just now you can see it move away from the earth. Okay, because it move refracted towards the normal line. Okay, so that's why it will move away from the earth. Okay, and here, okay, during the night time, okay, it travel from the dense to less dense, so means it refracted away from the normal line. Okay, so when it refracted away from the normal line, it will move towards the earth. Okay, so that's the reason. Okay, so we already finished for the refraction of wave, so I will give you questions, okay, for tutorial. All right, so let's answer this question. So okay, for those just entered the class, I give you the link. Okay, you can join using the link and also the code. Wang Shen, you already know who is still not here. Alice Ethan. Okay, thank you. Okay, Jiang Wei. Thank you. Okay, so where's others? Where's your answer? So it says here, which of the following show the effect of the wave when the water wave is moving from a deep region to a shallow region? Why I can join? Um, you cannot join. Why? You said what? Did you enter the link? Did you put the code there? 72775. Okay, can you give me your name? Then I will remove you from the list, then you can join again. So who still cannot join? Joey? Okay. Jia En. Wait, I found your name. I remove you, then you join again. Jia En. Oh, not here. Jia En. Jia En. Okay. Then Kianjin. Okay. Try to join again. I already remove you. Yong Wei. Okay. Cheng Chi. Cheng Chi. Okay. Then Joey. Daniel. Daniel also cannot join. Daniel. Okay. Lu Ling Jing Yi. Wait. Lu Ling Jing Yi. Okay. Ng Jing Yi. Okay. Lim Kian Zing. Wow, so many cannot join ah. Kian Zing. Okay, Wei Lok. Okay. Wow, so many. It seems that it has an issue. Okay, why not? Then why the four people can answer this one? This question. Wendy, Zhui, Shuyan, Kavinish. Still cannot join. Okay. How about we make a new code? Okay. We make a new code. Okay. But then we make a new code. Okay. Sorry. 547673. Okay, we make a new code. Using the same link, my class point froze. Why not we try again? Then they say if still happen, then we use a normal one. Just use the PowerPoint. I give you the code already, and also I give you the link. Wait, I send the link. Sorry, class. Okay, so we wait for 26 more. My class one always freeze whenever I press on join. Are you using your phone or using your laptop? Changing. For those who are using the phone, you can just scan the QR code here. You don't need to open the web. Yeah, yeah. It's okay. Because yeah, I didn't share my screen yet. It's okay. For those who got, they say it's not in slideshow. It's okay because I'm not sharing it. I also use laptop. For those, yeah. For those who are using phone, you can use the QR code. Just scan. You don't, and you don't need to enter the code. You will always just go directly to the slideshow. Yeah. Maybe you cannot use the link to join. Maybe you have to use the QR code. For those who use laptop, I'm not sure. I think you have to use the website. I think before this, when we use it before the holiday, everything is okay, right? Maybe they got the server problem. Okay, I'm still waiting for um, 15 more to join. They say if you cannot join, you can just use your phone. Okay, so we wait for another um a teacher. I cannot join. Also laptop also. Oh really? How many of you cannot join? If you cannot join, you can tell me. So same. Okay. So if you cannot join, right? So what you can do, you just see the screen. Okay. I will share the screen on the Google Meet. Right. Okay. So we move on. Okay. For those who cannot join, so 29. Maybe you have an internet problem or something, or maybe my internet. All right. Maybe class point server. I'm not sure. So let's try to answer for this one first. So let's say if the problem still happen, then we just use the normal PowerPoint, right? All right. You can give the answer in the chat. For those who cannot join the class, okay, using the link or the QR code, you just write your answer in the chat. Okay, can write the answer in the chat. C. C, C, C. Okay, so 14 more. So it says the wave travel from the deep to shallow region. So means there must be a change in the speed and also in the wavelength. Okay. C. Okay, quickly for those who still didn't submit the answer. Still got 14. Joey, teacher already submit. Okay. Then I can remove you here, right? Joey, 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 Joey. Here. If you already give me the answer in way. Alright, so I will close. Alright, so let's discuss the answer. Okay, for this one it says it travel from the water, it's a water wave that travel from the deep region to the shallow region. So for the deep region, you already know the wavelength must be bigger, right, than the shallow region. Okay. Okay, while the shallow region, okay, the wavelength will be closer to each other. Alright, so for this one, the speed, yes, the speed is decreased. Okay, since the wavelength is decreased, okay, the wavelength decreased, the speed also decreased. Okay, and then the wavelength also decreased, correct, but the frequency is constant. So the answer should be C. Okay, okay, very good. C, 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 C. Okay, Joey, the answer is D, C. Why your answer is, sorry. The answer is C, not D. Lavanya, the answer is C. Why you answer D? Wait, I see the question first. Why you answer D? Okay, so some of you answer D. So let me check why you answer D. So what is the D? D is increase, increase. Okay. For deep to shallow area, right? So for deep, remember the wavelength is further, okay, then further with each other if you compare with the shallow region. Okay, so the answer should be C, not D. Okay. So the next one. Okay, this one you have to calculate. Okay, so what is the formula for the refraction of wave? So V1 lambda 1 is equals to V2 over lambda 2. So V1 lambda 1, you can take the deep water. Okay, for the deep water, okay, the speed and also the lambda or wavelength for the deep water. V2 and lambda 2, you can take the shallow water. Okay, from the shallow water. So speed and also wavelength. Okay, so some of you already answered. The answer is B. Okay, I give you like 40 seconds more, okay, to submit your answer. 2.5 cm per second. Okay. Okay, so I will stop. Alright, so let's see the answer. Okay, so V1 over lambda 1. Okay, so it says here if the speed of water wave is 5 cm per second in the region of deep water, so means here the speed is 5 cm s negative 1. Alright, and ask you to calculate the speed of the water in or water wave in the region of shallow water. Means you have to find V here, speed here. So V1 lambda 1, so I will take the deep water as V1 and lambda 1. Okay, so V1 is 5, lambda 1 is 3. Okay, and then it's equals to V2, you need to find lambda 2 is 1.5. Okay, so you just cross multiply, you get 7.53 V2. So V2 you will get 2.5. So the answer should be B, boy. Right, so very good. So most of you got answer B. Okay, so let's check for those who submit. Okay, so far okay. Very good. All right. Okay, so let's see the next question. So the diagram shows the pattern of water approaching a shoreline. So which is the most suitable location for a child to swim? So this one I remember I told you about the bay and also the cape, right? So you can see what happened at the bay and what happened at the cape. Right? So which one the energy is dispersed, all right, and it will produce the high wave, and which part will produce the low amplitude and the water is more calm. So usually if you want to swim, you will choose the calm water, okay, the part of the beach that have the calm water. Okay. Okay, some of you got Xenon, got B, others, some of you got C. Okay, I give you like 30 seconds. Okay, so I will stop. Alright, so here it says the diagram shows the pattern of the water approaching a shoreline. So which is the most suitable location for a child to swim, right? So here you can see the energy here, right? The energy here will be dispersed, okay, or will be spread out. Okay, but this one, the energy will be converged, okay, at one point. Right, so mean here the water is more calm, right, compared to A. So the answer should be C. Right, so let's see. So most of you got answer C, very good. All right. Okay. Thank you for your response. All right. So the next part. Okay. So remember the deep area will produce the higher wavelength. Okay. If you compare to the shallow part. So let's say if I put the ripple tank. Okay. And I put below it, maybe I put a screen or white paper. Okay. So what way can I see? How is the wavelength? Okay. I give you 20 seconds more. All right. Okay, so here it says diagram 3 shows a ripple tank with a sloping base and a vibrator being vibrated. Okay, so here you can see this is shallow part and this is the deep part. Okay, so means that shallow part the wavelength here should be shorter, okay, or should be closer, okay, if you compare to the deep part here. So the answer should be A. Okay, so let's see your answer. Low Ling Jingyi is wrong. Okay. Deep area, higher wavelength. Okay. Shallow area, the wavelength will be much closer. Okay. Very good, Alexis. Okay. So the next one. So this is same as question number 4, I think, right? The deep area will produce the higher wavelength, okay, while the shallow area will produce the shorter wavelength. A. Okay. All right. So we close the. All right. So let's see the answer here. So here you can see this is the shallow part, right? This is the shallow part here, and this is the deep part. Okay. So means here the wavelength will become longer if you compare with the shallow part, right? So it should be the answer is A. Okay. So number 5 is A. Okay. Very good. If you can answer using the class point here, I think it's better for you to answer here because this one I will proof. This is as a proof as your PBD, okay, for this chapter. So if you can answer for this one, it's better for you to answer at the class point. So I will keep this one as the proof for your PBD. All right, for this one, okay, so it travel to the different depth, okay, and but be careful. This one is it's like a concave, right? Concave lens. So you have to know what is the characteristic, okay, for the wave that pass through the concave lens. So what will happen? Okay, I give 30 seconds more. D. Okay. All right. So here it says a different depth. So mean if you put the lens here, okay, if you put the lens here, convex lens here, so it means it will become this at this part it will become the shallow area. Okay. So for the shallow area, of course you have to know the wavelength will become shorter. Alright. But the shape of the wavelength also will become different. Okay. So it will be changed, right? So it will follow the shape of the convex lens. So the answer should be D donkey. Okay. So for this one is correct, but the difference is the is wrong because the wavelength is same. Okay, this one the wavelength should be shorter. Okay, so the answer should be D donkey. Alright, very good. Okay, for those who still didn't go to take their module, you can go to take your module, the one that you already paid. Okay, so please go and take. Okay, I think I saw it last week still at the canteen. Okay, so please go and take. All the notes from chapter 3 and to chapter 6, okay, will be there, including the one that I'm giving right now. Okay, so the next one. So this is the concave. What happened to the wave after it passed through the concave? Okay, this is like a concave shape, concave lens. So what will happen? So at first, of course, you know, at the here, at the perspex block here, the wavelength will be changed, right? Because this one will become the shallow area. Okay, the wavelength should be changed because this one will become the shallow part, okay, of the water, and this one should be deep. Okay, but how about the shape of the wavelength? Okay, some of you said A. Okay, some said B. Okay, I give 15 seconds more. Okay. Alright, so some of you said A, some of you said B. Okay, so for A, you can see the wavelength there. So is there any change of the wavelength if you compare from deep to shallow? So yeah. So is there any difference? So I think for A, right, the wavelength is same as the deep area. Okay. So there is no change of wavelength. Okay, well, I already told you when you put the blocks, okay, on the ripple tank. So at the part that you put the perspex block, the part will become shallow. Okay, so that part will become shallow. So that means the wavelength will become shorter. Okay, so the answer should be B boy. Okay, the answer should be B boy because at this part is a shallow part, right? So the wavelength should be closer. Okay, if you compare to the deep part, right? But the shape of the wavelength is correct. Okay, it will follow the shape of the concave here. Okay, so the answer should be B boy. Right, so A wrong, B, C. Why C? C mean it reflect back. No, okay. There will be no reflection here. Okay, it will pass through the blocks. Okay, B, 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 correct. B, 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 B. Okay, B, 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 B. Okay, so the answer should be B. Alright, for this one, you have to type your answer. So this is the SPM questions. Okay, you can type your answer in the chat. So let's say you put A, what is your answer? B, what is your answer? So what happened to the speed of the wave in the shallow water region? So if the question asks you what happened, okay, what happened to the speed, what happened to the frequency? Usually the answer should be increase, decrease, or no change, right? See, I see one already submit the answer. A. Refraction. B. Decrease. Okay, I give you 30 seconds for you to submit your answer. Okay, please do submit your answer. It's okay if it's wrong. Okay, so I give you 20 seconds more. Then we will discuss. Okay. Alright. So it says diagram 2 shows an image of plain water wave as it propagates from deep water region to shallow water region. Right. So name the wave phenomenon shown in diagram 2. So you can see there is a wave change in wavelength. Okay, there is a change in wavelength and also the direction of the propagation. Okay, so this one is actually the refraction of wave. So you have to remember when they said about the wave phenomenon, there are 4 wave phenomenon, okay, that you learn. Okay, so but now you already only learn reflection and also refraction, right? So there's another 2. There is a diffraction and also interference. So that is a 4 wave phenomenon. So if they ask you what is the wave phenomenon, so you have to give whether either these 4 wave phenomenon. There is a reflection, refraction, diffraction, and interference. So for this one, the answer is refraction. Alright, refraction. Okay, what happened to the speed of wave in the shallow water region? Okay, so you can see here the wavelength is decreasing. Okay, so when the wavelength is decreasing, so what happened to the speed? So the speed also will be decreased. Right, so the answer is decrease. So let's see your answer. Refraction, very good, Xiong Wei. Dancing, elections, very good. Right? No, why decrease? Fixed size of slit? No. Okay, increase, no. Why fixed size of slit? Slit is a diffraction, not refraction. Okay, if they involve the slit, means that one is diffraction, not refraction. Okay. All right. So for this one, you have to draw. Okay, but maybe I will keep the answer for the next class. Okay, because you can only some of you can use this class point, right? So I will not use, because this one you need to draw, so you cannot put the drawing in the chat. So I will keep the answer for the next class. Okay, when all of you can join. Okay, so then you have to draw. Okay, so let's try for this one. Junkiat is decreased, okay, Junkiat, because the wavelength decrease. You have to refer back to the formula. Okay, usually when the question asks you what happened to the wavelength frequency, or maybe what happened to the heat or what happened to the volume, okay, so you have just refer to the formula. You can get the answer from that, from the relationship from the formula. So what the meaning, what does it mean by wavelength? Okay, You can find the meaning from the notes if you already take the notes. Maybe you can find your textbook. What does it mean by wavelength? Usually, if in the diagram, okay, how do we label a wavelength? One wavelength is actually equals to what? So let's say we have a diagram here, right? Okay, so the diagram here. So how does we explain? How do you find one wavelength from the diagram? Usually we will say from this is crest, right? So from crest to crest. Yeah, this is equals to 1 lambda. So if you use a diagram, maybe you can just show what is the wavelength. So if let's say they give you like they ask you to describe in words. So how can you describe it? Yeah, very good. Two consecutive points in same phase. Okay. So I give you like 30 seconds more, then I will close. Okay. 7 seconds more. Okay. Alright, so what does it mean by wavelength? So the distance, okay? Distance, right, between two consecutive points. Okay. In same phase. Right, so that's the meaning. Okay, so let's see your answer. Distance between two consecutive. Yes, correct. Two successive crests or throw. Yes, very good, Yin Hui. Two adjacent point at the same phase. Yeah, must be at the same phase. Like maybe from crest to crest or throw to throw. Okay. All right. Very good. Then let me check your answer in the chat. Okay. So most of you got it correct. Okay. Very good. Okay. Let's move on to the another one. So this one is a comparison. All right. So you can use a symbol here. Right, if you want, or you can put in the long sentence. Okay. So is it okay? Can you answer for this one? Can just use a symbol. Okay, this one symbol or this one, or maybe this one. Just put like A is bigger, higher than B. B is smaller than A. Okay, so for those who cannot answer at the class point, you can use the chat to answer. Okay, Zinye, thank you. Okay, I give you like maybe 30 seconds more. Okay, kau jungkit. Greater than the depth of the water is greater than the depth. Okay. Okay, so we stop now. Oops. Okay, so let's check the answer. Okay, it says here, based on diagram 6.1 and 6.2, you have to compare the wavelength. Okay, from region A and also region B. Okay, so you can see here region B, they got the shorter wavelength if you compare with the region A. So you can just put here, okay, wavelength. Okay, wavelength of B is shorter than A. Okay, or you can say A is bigger than B, also can. Hmm. Alright, and then the next one you have to compare the incident angle theta 1 and also the refracted angle theta 2. So the theta 1 you can see here the angle bigger than the theta 2. So you can say incident angle, okay, theta 1 is bigger than refracted angle, okay, theta 2. Okay, and next you have to compare the depth of the water region A and B. Okay, so the depth of the water, okay, region A is bigger than depth of water region B. Region B. Okay, or you can say the depth of the water region B is smaller than the depth of the water region A. Also can. Okay, vice versa. Alright, so let's check your answer here. A is larger, constant, no. In refraction, the only thing that constant is the frequency. Okay, you can see if you see closely, right, the angle here. Okay, of course the angle theta 1 is bigger than theta here, theta 2 here, right? If you compare the angle. Yeah, A is steeper. Okay, A is steeper, correct. A is higher. Okay, no, it's not same. Okay, A is higher. It's hidden. Mm-hmm. And also you have to know when the refraction occur, right? So that one is from the less dense to denser, right? So it will the direction of the propagation, right? The direction it will become towards, right? It will move towards the normal line. So that's why the angle become smaller, okay? Because it's refracted towards the normal line. Mm-hmm. Mm-hmm. Unsure, okay. The depth of the region A is deeper. Okay, very good. This one is what, Kavinish? What is bigger than what? Okay, wrong. A is bigger than B. A is less than B. Is bigger. Is than. Okay. Mm-hmm. We can just answer it like this also can. But later when in exam you have to put the words means what is A, the like this. Okay, wavelength AB is bigger than A. If you want to use a symbol, okay, you still have to put the quantity here, the physical quantity, wavelength, length, okay, time, okay. So you have to put, don't put just B is smaller than A, okay. Put in the words. All right. So let's see the next one. So the relationship you can use the graph relationship inversely proportional, increasing linearly, or maybe directly proportional. Okay, but remember in the graph for the relationship you cannot put the higher that one cannot. Okay, for the graph only that the answer that being accepted is only directly proportional, increasing linearly. So it depends on your graph. So for this one, you don't need to copy all the sentence, okay? So you just put C2, okay? Just put like this. C2, okay, what's the answer for the first one, comma, and what's the answer? No need to copy all the sentence. Okay? Is it okay? So here you can put, there are two ways to answer, okay? Whether you can describe whether it decrease or increase, or deeper, shallow, or you want to start from shallow to deeper also can, or you want to start with deep to shallow also can. Directly proportional, deep to shallow towards. Okay, very good, Zinian. So I give like 1 more minutes, then I will close. Okay, before I forgot, so our presentation will be only on Thursday. So on Thursday, 1 hour is for your presentation for project. Okay. So the class only will be on Monday. Okay, 20 second more. Okay. Alright, so state the relationship between the depth of the water and the wavelength. Okay, so directly proportional. Okay, so here what you can say, the deeper, okay, the depth of the water, the higher the wavelength. Okay, so that's the answer. Or some of you put directly proportional, also can. Okay, so that's an answer. So here you have to complete the sentence. Okay, so it's up to you. Let's say if you start from the, when water travel from deep, okay, to a shallow region. Okay, so from deep to shallow region, the direction of the propagation will be refracted towards the normal. Okay, but let's say if you start from shallow, okay, to deep, okay, so the answer should be refracted away from the normal line. Okay, so it's up to you which one you start first, whether you start from deep or you start from shallow. So let's check your answer. Directly deep, shallow toward, directly A to A, B. Okay, so this one is wrong. Okay, toward, deep region, shallow, bend towards. Okay, very good. Directly deep towards, depth, wavelength bigger. Okay, deep, shallow towards. Okay, decrease. So this one decrease, deep, shallow toward, directly proportional. This one is not away, it towards. Away, if the wave travels from the denser to the less than medium. Okay, so okay. This one you start from swallow. Okay, I got it. Yeah, correct. Okay, very good. This one, deep to shallow towards. Okay. All right. So give me some time to check the answer at the chat. Okay, deep, shallow. Okay, shallow, deep, away. Okay, correct. Okay, so for this one, you have to explain, all right, why most beach resort, okay, are built at the Bay Area compared to the headland. Or maybe this one they want to say at the Cape area. Why they built at the Bay Area? So this one is the same why we swim at the Bay Area. And the answer is almost same. So two marks, so means 2 point. Okay, maybe you can explain from the energy part, right? The energy part of the wave. Okay. What is the energy, okay, at the Bay Area? Whether it's high or low, so what they will produce. Because the Bay Area is less deep, so the wavelength will decrease the kinetic energy. The kinetic energy. Hmm. Energy wave diverge more safety. Okay, so where's others? Less energy to coverage at the bay to converge at the Bay Area. Okay, what's the answer? No one submit yet. Okay, so let's see the answer. Okay, no one answer this question. So, alright. So explain why most beach resorts are built at the Bay Area compared to the headland. So, the first point you have to say, okay, the energy, okay, energy of the wave is being, okay, dispersed, okay, or you can say being spread, okay, it's being spread. So the water, okay, the water more calm, okay, at the Bay Area. So 2 point. Okay, so that's the answer, right? So some of you try the kinetic energy. I'm not sure. I don't think it's about the kinetic energy. It's actually about the wave of energy because of the change in the depth of the water. Okay, that's not about the kinetic energy. Okay, kinetic energy is usually depend on the heat. Okay, they didn't mention about the heat here, so this is not the kinetic energy. So the kinetic energy, maybe you can use that one is for the reflection of sound, right? From the hot area, the hot air at the bottom part of the layer of the air. So that one is a hot area. So the kinetic energy here, that one is higher. That one is for sound can, but for the water, no. Okay. Because they didn't mention that they heat the water or something. Okay. So the kinetic energy, you have to relate it with the heat usually. Okay. So I think I will stop until here. So I see you on Thursday. So please be prepared, okay, especially for the technical problem. Okay, like for us just now, they got a lot of the technical problem. The video cannot be played, the sound cannot be heard. Okay, so please do, like maybe you can ask your friend, okay, Google Meet, okay, then he see your presentation. Okay, so I see you on Thursday. So please be prepared. Okay, so take care class. All right. So thank you. Okay. So sorry for those who cannot join the class point. All right. So I see what happened. Okay, after this. Okay. So take care everyone. Bye. Okay, welcome.